and then whoever said example.
All right, let's take a look at the laboratory.
Is there like a page limit on the
No. Content. Okay. So if we take a look, it has been found that thiosulfate ion in sodium thiosulfate decomposes when it is in presence of an acid. We are using hydrochloric acid. This is the sodium thiosulfate. So if we recall last semester, anything that is with sodium will dissociate or dissolve, right? The solubility table. Remember all of the alkali metals? I know it's been a while, but so this thiosulfate ion, S2O3 negative 2, will be dissolved. It will then basically react to give you sulfur, which is a solid, and the other two are aqueous. Notice this acid with the H here, that is sulfurous acid. So what we care about is that solid sulfur is formed. When the solid sulfur is produced, it is white or yellow. You'll see yellow probably. That causes the solution to turn cloudy. Eventually the solution will become opaque. Opaque means you cannot what? See through it. Transparent means that you can see through it, and translucent means that light can go through it, right? So translucent would be like a bath shower door or church glass. That would be translucent. Transparent would be like a window.
I thought translucent meant you could still see it if it was just distorted in some way.
The light, yeah. So I mean, remember your eyes see only light and the reflection off of things, right?
Right.
So that you were saying the same thing. Light can pass through it, but yeah,
I did not know.
You cannot see a visible image.
Right.
Yep. Like a clear image. Yeah.
Like even though you might see something, it's not. Okay.
Perfect. You will use this fact to determine how long it takes for the reaction to occur. You will time the reaction by timing how long it takes before you can no longer see a mark on a piece of paper underneath the flask. If you start timing the reaction as soon as the acid is added, very good data can be obtained. So basically you're going to make a bunch of concentrations, 4 to be exact, and then you're going to pour the acid in, and then you're going to click a timer. Or probably on your phone, right? What do we expect? The less concentration should take, lower concentration should take the most time, right? So compare the time it takes for the cloudiness to occur when different concentrations of thiosulfate are added. Measure the time in seconds, calculate the reaction rate, and plot it against the concentration of thiosulfate. Determine if the relationship occurs between the rate of reaction. Basically, we want to find the order of the thiosulfate for this. Here's what we'll be using. Erlenmeyer flasks. Have we used those yet? Let me grab those real quick. Yes. Did you see our celebration?
Oh. Wait, is a glass full of water translucent now? Because it distorts whatever's on the other side, even though it looks.
It's more transparent, I think.
Well, that's what you would think.
Like pure water.
But because it like refracts images.
Well, you can see clearly.
You can still see it clearly, I think. Yeah. It's a hard one though.
Okay.
So, this is an Erlenmeyer flask, right? The thing about this is everything has to be completely clean. Otherwise, you're going to end up wasting a bunch of time because the reaction will start to take place if everything's not clean. If you sit there and you're making these chemicals and the reaction starts taking place and you're not paying attention, then obviously you're not going to get done, right? Does that make sense? So you need to make sure you clean everything out real good. This is extra dirty. Let's try that again. All right. So somebody should be on cleanup duty. And remember what I said about soap. This is enough soap to probably get all of these. this is not a great way to set these unless you know that nobody's going to be over here messing around, right? So be careful with that. So let's calculate out how much of the acid we need. So we're going to need 10 milliliters how many times?
4?
4 times, so that's a total of 40 milliliters. So we can use which of our beakers for that? The 50 milliliter, and then just go almost to the top, right? So that's one thing. How much thiosulfate are we going to need? Not everybody at once, please. I can't understand you if you do that.
Oh, 110.
Are you serious?
No. I'm not serious. We need. I'm confused.
In a 250 milliliter beaker, 400.
Don't like. We're thinking. We're not just reading directions, right? We're
Oh.
thinking. So go to the data table 1 again, and add up how much thiosulfate we need.
Oh, the data table.
So it's 4 trials. The first one takes how much?
Oh, I was not on that page.
100? Where are you guys reading? Huh? But what's the volume of thiosulfate we need?
10 milliliters and 20 to 30.
Okay, so what's the total volume? 10 plus 20 plus 30 plus 40, 100. Okay.
Yeah.
There we go.
Thank you.
I said the first one, though, yeah. You were giving me the answer of what I wanted a few minutes ago, not just then. Thank you for that. So if we take a look, you'll need 100. So what size beaker should we get for that?
The
200.
250, right? There's reasons why the instructions say stuff, but I want to show you why that is. Does it say 100 for the HCl? Or does it say 50? We know we only need 40, but it might say 100 because...
It says.
It says
100 milliliters.
Yeah. Why do you think it says 100 milliliters?
Because accessible.
More space.
Yeah.
But you should not fill it all the way up to 100, right? You should fill it up only to...
Yeah, excess space. It should only
Yeah.
be up to.
It should only be up to 50 still. Right? Why do we even go to 50 if we only need 40?
so the air.
Yeah, right. Remember the technique to make sure this is dry. Always make sure that you can hold on to some of it. Otherwise, what will happen?
Look, it's
It'll get stuck.
Did you guys not do that? Like,
No,
You
we,
know.
No,
we rolled up the paper towel.
We just went upside.
We like stuck it.
wait, you.
So here we have a not cleaned one. And I just want to show you that it's possible that the reaction now, if I didn't clean this, the reaction could be taking place at this point. Right? So I'm going to cheat clean this one. We'll see if the reaction takes place there. I'm going to go ahead and take 25 of this. I know that you guys don't have one where you take 25.
Wow.
Slay, Mr. Jackson.
Right?
And that's HCl. Yeah.
That is the thiosulfate. HCl is over here on this table.
Oh, thank goodness. You're not just pouring it.
And for all of these, we need how much of the HCl? 10. Well, I was off on that one, though, right?
I'll do more nightmares tonight, guys.
Remember, you'll bring yours over here to get the HCl. These never go to your table. These never go to your table. Only your beakers go to your table, right?
Yeah, so your hands don't fall off.
So that you don't leave it over here and everybody's like, where's the HCl? 10.
I'm pretty pretty sure no science teachers take safety precautions given when my dad taught science, he lit his hand on fire. He didn't really care. He was like, oh, okay.
So on this right here, you will have A, B, C, and D. The one thing you can do is do all your thiosulfate first and fill these up. You'll want to probably mark these as A, B, C, and D, right? And then you're going to have this smiley face right here. And you're going to use that to look through. And then you're going to add,
Oh, I thought you just wanted to encourage people.
you're going to add the HCl. And then you're going to start the timer. And then you're going to look down through there and watch that smiley face.
See how lit crazy he gets.
So what's happening right now is the reaction is taking place and we're forming what?
Sulfur.
Sulfur. That sulfur then will start to darken this. And as you can see, it is getting cloudier. And I'm looking down through here. And whenever I can no longer see it, I call it. That's the time of that reaction. So then you do that for all the trials there. And that's it. Does the same person have to look down through here each time?
Yes.
Yeah.
Yes. Otherwise, I'm not going to know how you decided to turn it off, and you're not going to know how I decided whenever I couldn't see it anymore, right? Also, our visions are different. So for this evening, you should go down through here and do the pre-lab, and then figure out the concentrations of the table 2. Figure out the concentrations of everything. You know the V1, you know the V2. Let me make sure that the concentration of this sodium thiosulfate is what you want it to be. What does it say? It says 0.2 molar, and yes it is. So 0.2 molar Na2 S2O3. You're going to use that to find the molarities for table 2. So that's what I got. And that lab will be tomorrow when you guys come in. Thank you.